Can't touch this.
All right. Hi, everyone. Who did not see my first talk, or who has not seen an MGMT talk of me before? Raise your hand. If you're really shy and you don't like raising your hand, just show me where you are. Anyone? No? All right. So there's going to be some assumed knowledge, so I'm sorry for that, but that's the deal. So just a really quick intro. I'm going to just show you some stuff. I showed some fun videos in my other talks, but you don't get to see them. I'm a hacker. I'm sitting down. Don't be afraid. I'm still here. I work on config management things. I write a technical blog called the Technical Blog of James. Who's seen my blog before? Raise your hand. And as always, if you haven't seen it, just raise your hand so I seem really popular. Everyone? Seen my blog? That's a bad joke. I'm tired. Sorry. So just some background. I used to work on everything in Puppet for years, and there were a lot of problems with Puppet, so I've sort of moved on, and I've been working on a new tool. Recently, though, past Puppet, sort of every day we're sort of like YAMLing, like Kubernetes has this YAML thing, and Ansible has this YAML thing. And the thing we're really trying to solve, the fundamental problem, is how we actually communicate what we want to our servers. And I just don't think that YAML is the right way to do that. So there's crazy stuff out there. Do we really want to be YAML programmers? Does anyone here want to be YAML programmers? Let's see. I don't think so. So this is a total nope. If YAML was the solution, I would love it, but I just don't believe that it is. And so everything is just totally nope. And so I have this tool called Mgmt. You've seen a bit of it before. So you haven't seen this talk. You're going to have to sort of memorize everything I teach you, go see the main talk, and then come back and be like, ah, very interesting. So there's two main parts. Again, just to recap, the engine and the language. The engine does a lot of cool stuff, kind of like Puppet, runs your graph of resources in parallel. And the question is, how do we build these graph of resources? And in fact, what we want to do is we want to build a graph of resources, and then switch to another graph of resources, and do this very quickly as often as we need to. And the language that actually lets us describe it is the special custom domain-specific language that we've built. It's very safe, it's very powerful, and it's very easy to reason about. So do you want to see some demos? If you don't interact with me, I will stop and leave. So do you want to see some demos? Yes. Thank you, thank you. All right, so let's just start off with something funny. What about Unicode? So I'm just going to, I'm going to show you the examples. Is that big enough for everyone to see? Yeah? Okay. So here's basically some code. I have this string, this Unicode string, that has all sorts of scary Unicode characters in it. And there's a print resource. That's what this is here, this block right here. And there's also a file resource. And that will actually create that resource, for example, this file, with the contents of that variable. Okay? So let's just run that. Oops. We'll run it here on the left, over that left, and over here we can see if the file gets created. So it does. And the cool thing is we actually remove the file and cat the file. You can see it comes right back. Because Mgmt is running continuously, and the resources also have events. So you can actually remove the file and cat the file, and even before the second part of the command runs, it fixes it. You can see Mgmt is sleeping until something happens, and it wakes up, and it fixes the state. And I've shown this before, but if I just watch, this is a watch command that will run something over and over really quickly. Oops. There we go. If we just run it over and over, you can see Mgmt is constantly waking up and fix the state. And it's so fast, you don't even see the file disappear. Is that cool? Very cool. And Unicode, right? So that was the spin. So that's just one demo. So this is how Mgmt works for every kind of resource, whether it's a file, whether it's a package on your machine, whether it's a real-time living virtual machine resource or a container or whatever you want. Okay? You want to see some more demos? Yes, good. Okay. Quick question, very quick. Yeah. Hang on, I'll show you that right now. So it's a great question. So the first thing, that was just a static example. But as I said, this language allows you to build real-time, or one of the goals of the language is to allow you to build real-time systems. So what if the values that go into things are changing over time? And what I'm going to show you right now is an example of that exactly. So I have this datetime function. I've actually shown this in the other talk, but I just want to show it again quickly. Datetime function, which takes the time, puts it into this value, combines it with this struct. And if we run this right here on the left, and I watch the file that it's making, it's making this file right here. You can see, I'm just polling the file to see what actually Mgmt is doing to it, and it's changing it every second. You can see this value going up, you can see these things going up, and so on. And I made a little view meter, so you can see if you make noise, the actual microphone that's building that string is in my computer and listening. So we're integrating all these real-time events and values into the resource, and this happens to change every second, but it might only change when the load goes up or when the load goes down and so on. Okay? All this is covered more in my first talk. So if you didn't catch that, unfortunately, we have to move on. This is the advanced scary talk. So first thing, let's talk about metaparameters. Again, this is the boring talk, but it's got some important things you should know. So all of these are metaparameters in MGMT. And what that means, metaparameters are things that modify all of the resources in a central way. So all of this code is built into the MGMT tool itself, and all of the resources support these things. For example, noop is something that says if you don't want the resource to actually do any work, if you set noop to true for that resource, it won't do any work. If the resource itself errors, then the retry metaparameter will let you decide, should you retry and try and run the resource again, or just fail completely, and so on. And there's a whole bunch of other ones. One of them is called auto edges. And here's the cool thing. So if you look at my laptop, or you'll see that something like this. You'll have a graph of resources. And the graphs, actually, each resource is the bubble, these vertices, and the arrows are their dependencies. So in this particular graph, you can see that this cause resource is a package that wants to be installed before this file gets created and so on. And if I just show you a quick example of this, I'm just going to show you auto edges. So the code is like this. And what we do is we just have a package resource, DRBD. We have a file, the folder for DRBD, and the service. And we say auto edge equals true for each one of them. Can you see that on the screen? That's the default, but I'm just putting it explicitly just for fun. And we put noop to false, but whatever. But here's the cool thing. Watch what happens when we actually run this. I need root because it's using the package. So what it's doing, it's actually autoing, so it's going on the internet checking the package. But I'll just show you right here. What it actually did is it detected, without saying anything to it, that the package resource right here has to happen before the service, and also that the package has to happen before the file. And so it automatically knew that it's silly to try and start the service if the package isn't installed. So we can do this for all sorts of different resources to make it less error-prone when you build your catalogs, so you don't get the dependencies wrong. And we do this, it's very simple. We just inspect the package thing, and if we find that there's a service unit file in there for systemd, then we know there's an edge. Make sense? Is that cool? That's going to save your butt, right? Okay. You want to see another example or no? If I don't hear resounding yeses, I'm going to stop and leave, and Bern's going to be mad. Do you want to see another demo? Yes. All right, slightly better. So here's the graph I just showed before. And it turns out if we were to run this graph, there's actually a way that we could optimize this. Can anyone think about that? How could we optimize? Just scream it out. So it's one big graph, and there's two disconnected pieces. That's true. So it turns out these blue things, so Puppet, if you're using Puppet or one of these traditional tools, what it would actually do is it would start up, it would install, say, the cause package, then it will shut down, or move to the next resource rather, shut down the package manager, install SL, do the same thing one at a time. And every time you start up the package manager and shut it down, there's quite a lot of overhead in doing that. So what we actually do for certain resources that support this auto-grouping feature, we actually will analyze the graph with a special algorithm, and it will actually group together things that don't have dependencies on each other and which can be combined into a single operation. So this graph and this graph are actually identical, except that now they're merging a few vertices which really don't have any dependency. So in this case, it'll actually run, and it will do all of those in a single operation, which will make things way, way, way faster. Cool? You want to see a quick demo of that? Okay, that was a quiet less. I think this is the right demo. Let's see. So you can see right here, this is basically the log message, and it says auto grouping. So what it actually does is it does it stepwise. So it grouped PowerTop, this package, into the cause, and it grouped SL into cause. So these are all now grouped into one big vertice. And let's just test that this works. Cause, hey. Okay, that works. And we can even have fun. We can do cause, hey OSDC, and we can even go crazy just to really check that cause is working properly. And that's completely nonsense, but it works. Okay? Make sense? Does this make sense? Yes. Hello, Germany. Guten Morgen. Okay. So, move on. You want to see more stuff, or we stop? Do you want to see more demos? Yes. All right. Okay. So edges. So how to express dependencies? So there's a few ways. We can actually create a dependency. So whether the first resource points to the second or vice versa. So that's with depend or before. But in addition, dependency is kind of like Puppet, like before and require. It's the same sort of idea. We can also have listen and notify, which means that when a resource changes state, it will actually send a message along that edge to the next thing. And I'll just show you the code because this is a very boring demo, so it's not fun. And all this stuff is in Git, so you can do this at home. This is basically what it looks like. So right here, we have before. So we have our exec resource right here. It's doing something, and it's saying that it should happen before exec2. And exec2 is just sitting there by itself. Okay? Pretty straightforward, not super fun. Let's move on. So here's the thing. So the really cool thing is when you write code and it runs, and you never have to wake up in the middle of the night because it crashed, right? Like, who loves programs that crash? Just be honest. Raise your hand. Yeah, we have the sarcastic man over here raising his hand for no reason. So how do we make it? So in Puppet, for example, there's this problem with undef. And you might have to like this undef value. And if you manage to pass an undef value into the content field, or in some of these fields, or if you try and do undef plus 4, all these things will basically cause Puppet to crash. Not crash, but shut down and be like, error, this doesn't make sense. So we want to build a safe language, and how we do it is, for this example, we'll look at the file resource. And at the bottom here, you can see I have this file, temp foo. It has some parameter called James. And the question is, do I want to just create the file and ensure that the file exists, or do I also want to specify the content? Right? You might just want to ensure that there's a content that's there, but not actually say what's in the contents. And that's the difference between undefining the content or specifying the content. And the way we do this, you can actually just specify content equals some string, or we can use this little colon equal symbol, which is called the elvis operator. And it takes a Boolean value right before. It's kind of like a ternary, but it's missing one of the conditions. And this means if it's true, it will actually use this string. If it's not true, it'll be undefined. And this is actually the way we avoid any nil values in our program. So there's no such thing as a null or a nil or undefined in the language. And because we don't have those values, we can guarantee that there's never an operation where a string tries to add together with a nil, which would crash everything. Does that make sense? So I can show you an example of this, but again, it's super boring. But I'll show you right here. Again, all this is in GitHub. So very simple. That's exactly the same example that I showed you. So this Boolean here is true. So we'll run this. And if we cat Mgmt elvis, you can see that it has the right thing. If we remove it, it comes right back. And if we move this to false, just for fun, and save, and we run the same thing, so the file is there, but if we echo foo into this file, you can see that it did not change the content, right? So it's guaranteeing the file's there, and if we actually remove the file, you can see that it put it back, the file is there, but it has no contents. Was it okay? Can you see at the bottom of the screen? You can sort of see what's happening. All right? So that's how we do that. And many parameters can accept this undefined, and that's how they're passed in with the nil. Any questions? Does that make sense? Are you completely lost? Who's really lost and confused? Raise your hand. Nobody. Who is thinking this is awesome? Just let me know. That's pretty good. All right. So do you want to see another demo? Do you want to see another demo? Okay, good. Just some standard library functions. Here's a fun one just for showing you what's possible. So I have this code here, samples lang env. I want to show you env1. So we have packages. We have built-in system packages that you can use. One of them is FMT. One of them is sys. And here's just the sys package, and it has this env thing, which looks up the environment variables. So we have that, and we can just print if sys.has_environment. We're just doing like a Boolean right here. So if this function is true, we'll print some contents, and if not, it's missing. So let's run it, and we'll see. You can see that it printed out go path is on my go path, right? And if I were to unset go path and run it again, you can see now it says go path is missing. Cool? So little things, all these tiny little utility functions are in there. we have one of the MGMT hackers who's actually generating all of the functions from the standard library. So you should have basically all the functions that are in Golang very shortly. And if you want a new function that's missing, they're very easy to add. We basically just add the mapping from Golang to MCL, or you can just write a custom function that does something that we don't have at all. All of these things are needed. Our standard library isn't huge, but it's growing, and hopefully it helps. Quick question, yeah? So actually, for this function, you can or not. It depends on which function you use. This one does not have that implemented because in general, you don't actually change the environment variables from in the program. So it doesn't actually make sense for env, but other functions do support it. Maybe there's some proc hack where you can change the environment, but I think it's inherited. So I don't think it's actually possible, but I don't know. Yeah, so that's just one example. You want to see another example? Burned? Do I show them more or do I stop? All right. So, so how do we do iteration? So we want to so this language is basically something called an FRP. So it's a functional reactive programming language, and we do this to make it very safe because we don't want random like off by one errors and crashes and things. And the reason why we don't want those things is because if you make an off by one error, you might destroy a whole data center, right? That's super bad, right? You're having all this infrastructure as code stuff, and if you get really fancy, you're going to be using MGMT to build and destroy data centers based on load and other variables. So we don't want bugs, right? Because your boss is going to be super angry if you're like, yeah, I took out like, you know, the Deutschland data center. Sorry, boss, Amazon is down. So not a good idea. And so we don't actually have native for loops and this kind of primitive error buggy iteration in MGMT. But we do want to do iteration. So let me show you how this works. There's lots of ways, but let me show you a few. So I'm going to show you this lovely example. Okay. Iteration. So here's the code that I'm going to show you. So this is some MGMT code. We're going to try and guess what it's going to do, and then I'm going to run it. So over here, we just have a print resource. And we're going to try and count how many resources it's going to produce and how many edges it's going to produce. So if we count this, this here is just one resource. So everyone stick up one finger for one, okay? Or in your mind. Down here, we have a print resource. And it actually, instead of having a single string, which is the unique identifier for the print resource or for any other resource, we have a list. And it's this list here, which has two strings in it. So that's kind of a built-in form of iteration. If you have a list and you pass it into the name field, that is going to use both of those things. So together, how many resources so far do we have? Louder. 1, 2, 3, right? Good. Okay. So we have 3 so far. Down here, we have an inline list. So how many total is that? 5, yeah? And down here, we have more names. And how many is that total? How many? Yes, perfect. That's 8. I think it's 8. So I need you to hold up 8 fingers. You're going to memorize this value for us. Thank you. Don't move. Now let's talk about the edges, okay? So right here, this is a resource all by itself, 0 edges. Down here, no edges. Down here, we have this depend. Remember we talked about depend before? And it is saying these two resources depend on print and then this variable. So how many edges would that be? How many? It's 4, right? Because we have 2 resources, and they both are pointing to names, which is also 2 resources. So 2 times 2 is? Come on, this is doing math with James. This is super easy. There's no calculus. 2 times 2 is? Okay, some of you are losing your general education diplomas after. We're going to have to talk about it. So 2 times 2 is 4, plus all this down here. So we have more names here. And right here we have this, this edge, but it's defined apart from the resources. So you can just have it kind of like Puppet does, except the arrow actually points in the correct direction. So we have some number of resources here, and those point to some number of resources here. So on the left, how many do we have? Names? How many is this? That's 2. And over here, how many is here? That's 3. So 2 times 3 is 6. It's so much like, I don't know, is this a trick question? No, it's not a trick question. So 2 times 3 is 6, plus the 4 we talked. So 4 plus 6 is? Okay, so that's 10 edges, and how many resources did we have? Okay, let's run this. You ready to run this? This was the longest math example I've ever done. Okay, iteration, we're going to run this. And if you look, it'll actually tell you right here in the graph, 8 vertices and 10 edges. Congratulations, give yourself a round of applause. You are good at math. Very good, cool. Silly stuff. So that's how we do iteration, okay? There's other forms of iteration. Here's the math if you want to see the work. Map and reduce, we don't have these functions in core yet, but we're going to add these functions as well and some other fun things. So basic iteration possible. All right, so os.readfile. So let's just run this example because I have to run out of time. This is, oops. There we go. So here's a simple example. We have a file resource that's temp/output. And a content, which is whatever is returned from this os.read file, and it's looking at temp input. Okay? So let's run this over here. Okay, so I'm running MGMT here, and then I'm going to echo hey OSDC into /temp input. Okay? And over here, just so you can see what's going on, actually just watch -n 0.1 cat /temp output. Hopefully it's going to see the right thing. So it says, hey, OSDC, right? Because it's basically just reading that stuff in. It's a function that's a stream that takes values. And if we echo, hey burned and OSDC, and we put that into /temp input, you can see it changes in the background. Cool? So it's just a function that's built into MGMT, takes a stream of file contents, takes those strings and puts them in. Hey burned is this cool. Make sense? You want me to echo true? You can echo anything. Yeah. So basically, very simple thing, but just to show you, all of the functions are just providing real-world sources, and you can do weird copying things like that. You want to see another demo? Okay. So look at these two resources. Package resource, one is called cowsay, state equals newest, and another is package cowsay, state equals installed. These are both valid code in MGMT. What happens if you ran code that had both of these in it? What would happen? What should happen? So you would think it would install the newest version, and here's what actually happens. That's actually correct. So it will install the newest version, and what it does is it looks at these two things. In Puppet, what happens? Just for fun. Yeah. It errors. Duplicate resource. And in fact, that's actually not the correct thing to do. And the reason that's not the correct thing to do is because you might have different packages made by different people that both want the same package. And even if they're consistent in what they want, they all want like, you know, some utility package installed, they will cause a duplicate resource problem in Puppet, which is a bug as far as I'm concerned. So what this actually does is certain resources can check, are they compatible with others of the same name? And in this case, if we run this, right here, you'll see it actually works perfectly. There's no error. It installs the cowsay package. It's already installed. And no problem. And that's because if you say newest and you say installed, no problem. It will ensure that that's newest. Hang on a second. And the second version of this is, what if we have this version where one says installed and one says uninstalled? In this case, if we run that example, what's going to happen is an error. And it will say, graph state differs in an incompatible way, uninstalled versus installed. So any resource can support allowing you to have compatible identically named resources based on some metric or some design that's built into the resource that says, are these two things going to conflict or not? Does that make sense? Is that cool? You want to see more demos? I'm almost out of time, so I got to go. Here's how to do classes. We have classes and stuff in the language. I'll just show you this quickly. So basically, we don't have syntax highlighting yet, so please submit patches. Here we're just defining a class, foo. It has a resource inside. Here we have a class here that we're defining with 2 parameters. So you can have a parameterized class that uses those different values. And down here, you can include the thing multiple times because, again, duplicates are compatible if they're identical. Here we're just including bar multiple times with different input parameters. And basically, if we run this, you're going to get a whole bunch of stuff, basically exactly what we expect. So if you want to build composite pieces of classes and include them and stuff like that, all of this is possible. It all does the logical same thing, and there's documentation if you want to use it. Cool? I'm rushing through these things now. We're going to be building function values. That's not actually there yet, but this is coming very, very soon. So if you actually want to have a function that returns another function to do cool, crazy hacks, that's coming soon. State machines and oscillators. Okay, one last really crazy demo. And I think you're going to appreciate this one. So here is, I'm just going to run this on a single machine, but eventually this can run in the distributed system. But we're going to keep it simple because I don't want to scare you too much. So over here at the top, here's some boilerplate stuff. So don't worry about what's happening there. But let's look at what's happening right here. After that runs, we're going to build this state variable right here. And it has this big if branch that says, if the state equals 1, whatever state 1 is, we're going to set the contents of this text file to the string state equals 1 so we can see what happens. Then we have a timer, which is going to run. It's going to basically wait for 1 second so it doesn't go crazy. And then we have this key value resource, which is actually going to put the string state equals 1 into a special spot. And then we do the same thing. If we happen to be in state 2, set the file contents of state 2 and so on. And if we're in state 3, we set the state to state 1. So basically, if we're in state 1, we'll wait a second, move to state 2. If we're in state 2, we'll wait a second, move to state 3. If we're in state 3, we'll wait a second, move to state 1. Can you see what's going to happen? Yes? Okay, let's run this. Oop. So I'm going to run this here on the left. And I'm going to run this watch temp mgmt state. So I'm just pulling the file on the right, and you can see mgmt is running continuously. Oops, I dropped my microphone. It's running continuously, and it's switching from state 1 to state 2 to state 3. What we actually do is we've built an oscillator. Now, if you were to write this kind of code, this might be not what you want. It's a little bit scary, and maybe you don't want this. But in fact, real life, real infrastructure does oscillate. Hopefully they don't oscillate this quickly, but maybe in the morning, the sun comes up, the load goes up, you scale up some servers, the load goes down. We want to build these real-time systems. And this is how you do it. This is how I think you can do it. This is a single machine, but when we extend this, or with a scarier demo, we'll have multiple of these things running on different machines, and all the distributed state machines will interact to build really clever autonomous clusters. Does that make sense? So that would be sort of, think about when we move from state 1 to 2, we care about our current state, but we care that everyone else is also in that state. So that sort of thing, so we can synchronize on those steps. So pre-upgrade a cluster by doing a bunch of stuff, doing the upgrade step, waiting for everyone to finish, then starting the cluster service, all this sort of crazy stuff. Cool? Is that cool? All right. So we actually found a bug in MGMT because someone was running this at like thousands of times per second, and there's a really, really rare race which we patched last night. So hopefully we kill all these bugs. I don't have much time left, so I'm just going to finish. I have some more demos to show, but you'll have to wait till next year or next time I'm at a conference. There's ways to deploy stuff into a cluster. I'm not going to talk about this now, but you can ping me and get involved with the project, and you'll learn how we push code to the entire cluster and how this works. It involves your laptop, and it's super awesome. Scheduling I showed yesterday, so I'm not going to show that, but there's still lots of stuff to do, and I showed the magic CPU thing yesterday, so I don't have to show it today. What's left to do? I'm almost done. So write some code, like write some new functions in the library that you don't have. If you want to build something in your infrastructure and you don't have a function, you can add a patch to add them. New resources. We have about 20 or 30 different resources in MGMT, but there's some resources we don't have yet, which would be kind of cool. So we have an EC2 resource, for example, kind of like Terraform and that sort of thing, but we don't have, say, a Google Cloud one. So if there's one that you want to add, please let us know. Help get involved, or if you want, you could pay for one. We could hire someone to build it for you. Stuff like that. There's a few other things. There's very few bugs that are left. It's sort of on the final stretch of killing all the bugs and making this like 1000% production ready. So get involved. How can you help? You can use this, test it, patch it, share it with your friends, document it, start on GitHub, tweet it if you have Twitter, discuss it, hack on this stuff. And so I basically left my previous job to work on this sort of full-time, living off my savings, which totally sucks, and we don't have very much funding. And so if you don't want this to go proprietary, if you want to have this useful and free for everyone, you have to give me some money, because otherwise, yeah, free software needs people to pay. So send me some money. Funding a hacker is very sexy, so you should tell all your friends. Let's just recap.
Now let me recap.
It's my usual recapping joke.
Thank you.
We're on an IRC channel. We're about 70 hackers in there just hanging out. We have a Twitter account if you don't want to hear my rants on Twitter, but you just want to like get the MGMT news, check it out. Also on the mailing list, new releases, all those things, that goes out there. There's my technical blog, which publishes articles and different things, so you can check that out. And you can always find me, Purple Idea, on IRC or Twitter or GitHub or at Gmail, stuff like that. So that's it. If you want a free sticker, they're very expensive, but I'll give you one if you promise to put it on your laptop. Okay? And you can tweet me the photo, and I'll know that you used it for a good cause. Last thing you have to do, the very tall gentleman who's hiding in the back of the room is named Bernd. He looks like this. If you like this talk, go up to him after the talk and just poke him on the shoulder and say, hey, Bernd, James' talk was super dope. And if everyone does this, it will be like a distributed denial of bothering. So thank you very much. I don't know if we have time for questions. We have Martin, who's going to be giving a talk soon, so I'm sticking around for that. Maybe while Martin's getting ready, I can answer 1 or 2 questions, if you like. Does that make sense?
Yeah, thank you very much. We have time for 1 or 2 questions.
Yeah, sorry about that. Yeah, anyone? Raise your hand. Happy to answer stuff. I'm here till the end of the day, too, so if you have more questions and you're shy, you can always ask me in person. Anyone? Who's going to get involved and use this? Raise your hand. You're going to get involved? Anyone? Maybe? Maybe. Yeah, there's a question.
I'm not sure if I missed it, but is this how is the infrastructure behind MGMT working? Is it a client-server infrastructure?
Great question. Yeah, so what happens is, so Puppet, client-server, Ansible, orchestrator, we actually work as a distributed topology. So you actually spin up any number of agents on all of the machines that you want to manage, and they will automatically cluster together using the Raft algorithm. It's a distributed consensus thing, and that's how they communicate. So there's no single point of failure. They're just all these agents running everywhere, and that's how it works.
And where's the central stored configuration?
So that was the thing I was talking about with the deploys. So the way it basically works is if you want to deploy code to your cluster, you on your laptop or wherever your Git repository of code is, you run git deploy. It will bundle up all the code into a special like signed package and push it to any machine in the cluster, and that inside of MGMT will ensure that it's replicated everywhere, and then everyone will run that code.
So, but if I have a large configuration and large ISO files, I don't know the English spelling, and it will replicate it to every machine where I want to deploy.
So we cannot replicate extremely large files yet, so you have to limit the files to a reasonable size. In the future, what we will do is if you have an extremely large file, like an ISO that you want on some of the machines, then we will have selective replication that basically starts up temporary DHT, BitTorrent type things, and pushes those big files just to where they're needed, rather than everywhere.
Is it also possible to say, okay, MGMT, there's a central storage, like an NFS share or something like that, so I don't have to replicate every configuration file on every machine?
So the whole idea of a centralized thing is bad. I mean, we don't want this. There's so many problems with centralized store. However, if for some reason you really want to have a file store and you really want to pull files from it, then in your config, in your resources, just write a function that basically does a wget and pulls that file down, and that's what you'll get. I mean, I don't want that because I think it's a kind of a sloppy way to build your infrastructure, but if that's what you really want, then you could totally do that. I'm not writing that function as part of the core.
I can't imagine the idea replicating every configuration file on every server where MGMT is running, because most of the configuration files don't need to get replicated to this one specific server because they are not.
So people make this argument that like you don't need to share all that stuff, but the thing is the amount of configuration code is not like terabytes. It's like under a meg typically. It's not huge crazy stuff. There's no real serious negative overhead in replicating it. And that's just the elegant thing to do, because the whole point of passing the code everywhere is that everyone gets this distributed algorithm that you've basically programmed with MGMT in this MCL language. And independently, even if everyone else dies, you have the algorithm that you follow. And so it's possible that you could write some compiler optimization to erase some of the code that's not needed on that machine, but that's a lot of engineering effort for very little gain. So that's why we don't do it. Make sense?
Okay. Thank you very much.
All right. Thank you very much. If you want a sticker, come up and grab one.